exciting and big concern, right?
Yeah.
कौन excited है for PCB designing? Okay, सब है. So if you, I tell you guys कि it takes a lot of time and a lot of like prototypes to finalize a PCB. Would you like to like continue building upon your embedded design? It is something what we learn in like mechanical में जैसे CAD होता है, similarly it is for embedded PCB design. One good thing is कि normally we get a lot of modules, a lot of chips uh, pre-made from the company itself. But अगर तुम लोग को बनाना पड़ा, so there will be a lot of iterations. So how many number of people were there for embedded initially? Others can put down their hands. Initially, Pratik, Vinay, Mushir, Siddharth, 4 people. Okay. So today we will be teaching you guys more of a surface about what is there in PCB and what we are like when we design a PCB, what all things we keep in concern. Okay. We'll be showing you a basic PCB design. We won't go into more complicated part today. That would be more or less happening. Like we will not be including uh ATM 6050, ESP32, all those modules, but we'll be trying to add a few ICs, smaller ICs, and basic components, so that you guys first understand key how the platform works, and then how you can bring any component into that platform. Okay. So before starting everything, yep, is my screen visible?
Yeah.
Yeah. Yeah.
Yeah.
Yeah.
So when we talk about PCB designing, ठीक है, I hope कि some everybody is logged in now because there will be a lot of new things which will be coming up for you guys. So
Yeah.
before starting the PCB designing, can somebody tell what is like on book definition of a PCB?
It's a printed circuit board, so you have all wirings and housings done inside a single circuit board of between chips and other ICs and components.
Okay. Do you all like do you call the basic wiring as PCB or all the components included in within the whole board as PCB?
With all the components and everything combined, the whole package. Like if you exclude the external wirings, that is I'm talking about the internal connections.
Okay. More or less, yes. This is what PCB designing is. So printed circuit board, again, there will be a lot of wires, junctions, there will be through holes when you will be talking about that. And then this is all just wires. There will also be ICs, there will be basic components like resistors, capacitors, and inductors. You will be not only talking about like whenever we talk about PCB designing, we think about safe this voltage regulation. We talk about motor drivers. We talk about buck boost converters, all those like voltage conversion boards. There are like main IC boards. Even your motherboard inside your laptop is one of like a kind of PCB. So there are different variety of use case when you are talking about PCB designing. And what is the aim of a PCB design if there is already things present on the market? You'll find every module for each IC. Why do you need an extra PCB, custom made PCB?
Because everything won't fit your specifications and you have to fit in a lot of components and specific input channels for using the PCB. So that also helps you save space.
Okay, save space is fine, but all the specifications which you need, that depends upon the IC you are using. You're not going to build the IC, right? It is
Yeah.
already there, which like manufacturing company directly buy and install it on your PCB. So एक तो हाँ ये if you have to save space or make a custom size board, that's fine. What are the other reasons of making PCB?
Cost cutting?
To keep it simple.
Hmm. Yeah, go on.
Is cost cutting a reason?
Cost cutting. Okay, given that if you want to manufacture the PCB, your custom designed PCB on a scale of like hundred or thousands, then yes, cost cutting. But if you are needing just a single PCB, then it will cost rather more, because like when you will be ordering a PCB, that won't come as a single piece. There will be 10 pieces, identical pieces of the PCB. So if you need only one component, which happens most of the time, then it is not that beneficial, I would say. But if you want like that in the mass, then it's yeah, cost efficient. That is one point.
To keep the circuit simple,
Keep the circuit simple.
I
What
mean,
do you
like
mean? Hmm. Go
if
on.
we don't use a PCB board and we connect all the components, मतलब थोड़ी फैली सी होंगी ना चीजें. Like there will be a lot of wires here and there. So
हाँ, a lot
understanding
of
the circuit.
external
Hmm.
wires will be used, and जितने
हाँ.
external wires होंगे उतने loose connection होने के chances होते हैं.
Hmm.
Complications are there obviously, मतलब कि अगर एक खुल गया wire, you don't know where to put that back.
Hmm.
Those things are there. So
Um,
coming on,
Protection.
yeah, protection. Explain.
Like so PCBs are usually like grounded, like you can even create copper molded PCBs for grounding and all. So PCBs like can protect our circuitry as well in our housing.
Mm, I'm not sure what. Like, can you explain it further?
I mean, like I'll take leave the that case I mentioned, but for in more standard cases itself, like if we take an IC and then we attach a bunch of capacitors and resistors on the board, you will know one key how which one you're like you won't have any higher risk of shorting the board because you won't have again the same point that Siddharth mentioned. I feel like that falls into that loose connections part, but yeah,
Huh. And even if something like get fused or get short circuit, you can exactly pinpoint where it has been short circuit.
yeah.
So, that can be a one more solution that didn't came in the first time, but it can be a possible solution. Anyone else? Nahi? All
If
right.
we buy,
Yeah, go on.
like if we buy a already made board, then it would probably have certain like things that may clash with what we are trying to do. Like it has a
Mm,
certain extra component which we didn't need and stuff.
yeah, true. ये one of the issues होता है. For example, if you want to add a Wi-Fi system on Arduino board, normally like Wi-Fi is a like, bad example because normally you never get a Wi-Fi का IC circuit. It always comes on the module. But like any additional thing which you want to add, वो नहीं है already का, तो पूरा एक अलग से board लेना पड़ता है. You have to buy a board rather than that having that embedded inside the board itself. For example, IMU, GPS IMU. If you want to have a IMU sensor, you'll prefer it having it on the board itself rather than buying another module. So, yep, कुछ कुछ चीजें constrain कर देता है. Even sometimes let's say कि CAN module नहीं है हमारे पास Arduino में, again you could have used that for CAN communication. It has stopped, like it can normally help out अगर CAN module already उस पे लगा रहता, but that is not there. So all those situations में yes it can help out. So let's say for example you guys found out some issues on the already present boards and you planned upon making a PCB design. You It was your first iteration, you guys made something. You would feel like the aha moment. ठीक है? So what happens with parents normally? Like this was a slide to be taught by Daniel, but हाँ ठीक है. So normally your parents get excited, get hyped about whatever you like are. The presence of you is special for them. Similarly, you will get excited ki you made a custom PCB. You are pretty much excited, and then you don't understand ki there can be some addition, or like you can make a better prototype. You finally just take that the first iteration and use that upon your system. When you will like you had not stress tested it initially, it worked when you are using that single handedly just to check if the board is working. You find out ki, yeah, the board is live, you are like good to go. You put that on the main system and then poof, it goes off. So stress testing your boards is where like you get to find out ki what are the issues, especially when you will be talking about the threads in the copper size, the wires which go from one point to another. While talking about that, it comes a lot of times ki initially if you're putting some signal, it is fine. But whenever you attach an actuator which requires a lot of current, then what happens whenever there is a lot of current flowing through a very narrow like a copper wire, it normally melts the whole PCB and it short circuits. So realizing that you have made the PCB is not important. It is also important that you have stress tested it, thought about all the possible issues which can come along with your PCB design, and then reiterate the whole thing. Everything will not be done in first version itself. You may require multiple number of versions to finalize that thing, and even after that, there can be a very high chance that the PCB was the faulty thing out of the whole thing in the system. So इस चीज का like we have to understand कि this is one of the crucial part and place where it's more like hit and try. Like other things you can consider it like beforehand कि what will happen, but some parts are there where you usually go for the hit and trial method, try test it, and this is one of the locations where you fail the most of the time and you have to reiterate the whole solution.
So
So
just a question.
yep, yeah,
Can
go
a
on.
damage a short circuit in PCB damage other component as well? But most of the sensors are attached directly to the PCB now.
So पीसी whenever like it is sorted, it's like gone. ठीक है, इसके अंदर के कोई भी IC you can't use after that until unless yeah you go and test each and every IC if it is live or not, then put it back. But उतना नहीं effort डालते. If you don't have a PCB maker at home, you will no way going to use that again. तो पूरा का पूरा PCB ही poof, you have to use another board for that.
Got it.
Until unless we have another like a home inbuilt PCB maker जो बहुत ज्यादा कॉस्ट करता है. ठीक है. So
Yeah.
coming to the point again, which was told, ki why do we actually need to design a custom PCB? So a lot of time you will find out ki the market doesn't give you exactly what you need. Let's just say a very good example would be you want to yeah, you are using a battery, right, inside the system. You understand the requirements of the components inside your system have a certain voltage level, and like there is a safe limit of the voltage level, and just after a certain voltage you will find key that is the dangerous level you don't want after that. So normally what we use, theoretically we will use a Zener diode, right? You guys have heard about Zener diodes?
Yeah.
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 Can anyone tell me the function of a normal diode versus a Zener diode? Anyone? Okay, basically we use diodes in two ways in a circuit, right? Forward bias or reverse bias. Now can anyone tell me ki which one is Zener out of these two?
Reverse
It's
bias.
reverse
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 bias.
biased.
Okay. Bias, right? So the function of Zener diode is basically when you flow, like when you put a voltage which is more than its breakthrough voltage, then it works like a resistance, like zero resistance circuit. So basically that attaches the 2 points, and whatever extra current is required, that flows through that part only. So there is no like this is not like Zener diode is normally put in parallel with your IC circuit या फिर any load which you are using. So if there is some excess current, that will directly pass through the Zener diode, and the IC would be like safe. तो excess voltage हो गया, उससे बचाता है. Excess current हो, उससे भी कहीं कहीं handle करता है. There are different ways, ठीक है? And normal diode normally बस gives a way of like a single direction current. So normally we use like normal diode और Zener diode का यही difference होता है, ठीक है? So like yeah, that example was something. So then Zener diode, if you will go to search out, there are very different values of Zener diodes present in the market, especially in the IC form, SDMA, TFT, if you guys know about these two terms. जैसे हमारा resistance मिलता है about 50 rupees वाला. Similarly, there are a lot of different Zener diodes, and you would require a certain value of Zener diode which won't be present on the like board itself. So that will limit our situations. वो सब चीज का हम लोग को ध्यान देना होता है. That is another like additional point with the other points which you guys told earlier. So ऐसे कर करके कुछ specialized design होता है, कुछ custom values हम लोग को चाहिए होते हैं. Those things are not present with us. तो इसलिए हम लोग को custom PCB का use करना पड़ता है. So yeah, coming up to the next point, which softwares we use. So how many of you guys are present in RGs, like other societies like where this is used? Pratik, Udipto, Vinay. Okay, three people. So you guys would have heard about Eagle or Easy EDA, right? Or is there any other software which you guys use?
I use Altium.
Okay. Which team card?
Yeah.
Okay. Others?
I mean, in KRSST, like we were said, ki Eagle, but not into much because it started recently.
Okay. Aditya?
No, sorry. I thought you were asking who were in RGs. I didn't realize you were asking where we've used.
Acha. All right, no issues. So normally, like for example, for me, I completed a task for ARK. So they gave options between Easy EDA and Eagle ID. ID, sorry, Eagle का ही कुछ है. So these two were softwares which were given to me personally. So I had tried and tested these two. Also, KiCad is one of the like free softwares. ठीक है. So if you guys like, it is also available for Mac for free, open source है पूरा KiCad. And one which I am a bit experienced is Easy EDA above others. But Altium we are using at the end because there will be multiple boards which we'll be making, and you will find out soon enough ki, like this is something where you find ki which software is optimal for the amount of work which we are using. So yeah, Altium would be used for our uh, subsystem. In case if there are other like constraints, we would be going back to Easy EDA or KiCad. All right. So Soumyadeep,
Yes.
इसके आगे let's directly show them the software, I guess.
ठीक है. ओके. ठीक है. सो सब लोगों के पास ऑल्टियम है, आई गेस.
I have easy EDA.
ठीक है. uh, okay, let me share my screen. दिख रहा है क्या सबको?
अभी तक कुछ नहीं.
Yeah.
हाँ
विजिबल.
visible.
Yeah.
ओके. सो हम फिर नया प्रोजेक्ट से स्टार्ट करते हैं. ठीक है. सो या बेसिकली वी आर स्टार्टिंग विद अ न्यू वन. मैं तो बोलूंगा कि तुम सब लोग मेरे साथ ये खोल के बैठो ऑल्टियम, फिर फॉलो करते जाओ कहाँ से क्या हो रहा है. हेलो.
Yeah, we're opening.
अंडरस्टैंड तो सब लोग है क्या मेरे साथ या फिर नहीं है?
हाँ है.
Yep. Opening. Just wait a minute.
हम्म.
I have a question on opening Altium. There file name, if I go for new project, then the project part is like not showing, it's unclickable.
व्हाट?
Can I like how can you show how to open a new
या
project?
या यू वांट टू शो और यू
Sure,
वांट
I,
मी
I
टू
want
शो?
you to show me. Yeah.
ओके. या श्योर. ठीक है। Yeah. So basically, yeah. So um, basically start a new schematic, and you're ready to go.
Uh, Actually, right there, it's not. It's like for you, you could click on schematic. For me, it's hidden. Like I can't click on it.
Yeah, I'm also facing the same problem.
Can one of you show your screen? Maybe?
I think you guys haven't activated it. You have to go and activate your Altium.
Okay, okay. So you guys haven't activated. Okay. Someone just
Login.
show your screen, and I will guide you through it.
Yeah, my sharing my screen.
Yeah, screen is visible.
Wait, am I sharing my whole screen or wait? I'll
Yeah,
reshare.
you're sharing a whole screen basically. Yeah.
Okay, okay.
Okay, no license.
So yeah,
Hmm. Okay. Go to the corner, right corner,
yeah.
right corner. Yeah. Licenses. Get license. Okay. You're signed in with your profile. Yeah.
So I'll click on get license.
Yep.
Um.
हाँ ये इसी पे करना था. Yep.
Okay.
It will start working.
Ah, it's working. Thank you.
You'll be only able to view. You won't be able to do anything with the viewer.
Okay.
Oh yeah,
So.
it's showing it does not support, right?
Wait, I'll show my. I'll just share my screen कि कैसा दिखता है एक बार.
Hmm.
Can you see my screen now?
Yeah.
So I can go to my licenses. You'll have this.
You need to have that. And Udito, can you share a screen?
Yeah.
Because I think you haven't added the license. Yeah. Add license. Okay. Try refresh. Okay. Add license.
So, oh, okay. Connect to local server.
Mm, you have that email that you got while you got the access to Altium Designer.
I did with my IIT KJP email.
Yeah, you can just refer to that email for using this.
Um, yeah, I logged into this Altium using that email ID.
Yeah, I mean, you can use the mail contents
Oh,
to see
okay.
that.
Uh, this
Key student.
is
Uh,
this one.
yeah, after that, just go back. Yeah, Altium Designer student license. Yeah, you haven't verified.
Okay.
Yeah,
Acha, okay, I'll get the email shortly regarding this. Okay, okay, all right.
yeah. Confirm your email from here, from the Altium Education. Yes. No,
Uh,
confirm your account. Yeah, not that one. Yeah.
okay, all right.
So whatever Udipto has did now, yeah, you can just follow all those stuff and you will get the license activated. Now you can refresh in here to get the license added.
Okay.
Yeah, and you can now use your license.
All right, thank you so much.
Wait, uh,
Yeah, I can
just
finish.
let everyone do that. Tell me when you are done.
Who else has the same issue? Okay. Siddharth, let us know when you're done then.
I mean, I
Have you?
verified my email ID, but I'm still, no, like after refreshing, I'm not getting that one.
I wait. You will just get it
No,
in
I
some.
got the mail. Like I got the mail earlier. I when I verified my account, but I'm still not getting that. Like after getting the mail, do I have to do anything else?
No.
But yeah, like, wait, I'll
Yeah,
just
that
share.
mail regarding the Altium designer license, right?
Yeah, I
Like,
got that.
did you click on confirm email?
Haha, I confirmed the email. Then I got a mail called Student License Information for Ultimate Designer, in which my license information was given.
Yeah.
Yeah, that I did earlier. Like I got this mail on 30th June.
So still you don't have the license added to your account.
No,
Okay, show it once.
yeah, I got this mail, right? Uh, I got
Yeah,
this.
yeah.
Um,
Are you using the same?
oh, okay, now it's just appearing. Yeah, I mean it was
Yeah,
not showing earlier.
everyone ready for that, I guess. Yeah, so let's go to the new sheet. Okay. Um, let me know who is going to suggest me a schematic or maybe some circuit that we can do right now.
रेक्टिफायर कर सकते हैं.
Yeah,
Can do a rectifier.
you can do a rectifier just only with diodes.
I mean, more complicated means you can do a buck to buck. We can do a buck converter or something like that.
Yeah. Mm, my call is voltage regulator. How about you guys?
I'm fine.
You want to make a buck module, DC buck module.
हाँ.
Everyone. Hello.
I don't know what a buck module is.
Okay, so that's basically a DC to DC converter where the DC input will be something different from the output and will be basically either stepping up or stepping down, but not in AC domain, but in DC domain. Understandable.
Okay. Okay. It's clear, but how are we gonna make it?
Okay, so let me start with basic, a very basic DC module. We are going to do a DC-DC buck converter. Okay. Let me know what ICs are capable of doing this DC-DC buck conversion. Anyone? Nope. Anyone? Okay, Ayush, don't worry. The EVDA is a bit simple. I will go through that as well. Okay.
Yeah.
Until then, let's start with this. Just learn from here. Okay. Okay. So can you see this stuffs on the right? Components, manufacturer, part search, properties, explorer.
Yeah.
Are you able to find this stuff?
Yeah.
So tell me, what is the difference between component and explorer? Anyone? Yeah, I don't want to make a burden on you guys. Okay. So components is basically where you are going to search all the components you have inside Altium. Manufacturer part search is the vast library of all the manufacturer and maybe parts that are available in the market, okay, which is not or maybe available inside the Altium. Explorer is basically a detailed version of this thing where you can use the left side of the part, I mean the explorer, where you can see there are multiple parts, right? There are projects where you can have some kind of uh, designs you have made, maybe the components that are available in the cloud. Okay. So it's just like a file explorer, and for component, this is basically like drop down list or maybe a search list. Okay, this is a foldered version. So now, anyone tell me what are the basic components of a buck module?
Capacitor, diodes,
Anything else? You missed the
transformer,
important part.
transformer.
Transformer. Are you sure? Who is that?
Now, if we are reducing the voltage, then
Transformer is DC-DC transformer or AC? Tell me how transformer works.
yep, it works basically by that flux passing through that
So
wire.
does flux get generated while we are using AC or
Nope.
DC or maybe both?
Uh, it by AC.
AC only, right?
Yeah.
So obviously transformer is not an option. Anyone else? What is the components required for a buck module? DC-DC buck module. No one. So this is the schematic of a basic, very basic in fact, DC module. DC-DC buck module. So tell me what are the components that are required?
Voltage source,
Inductor,
inductor,
capacitor, diode, and resistor.
Again,
Inductor, capacitor, diode, resistance, and a voltage source.
uh, is voltage source a legit answer? Tell me. Because do you find a voltage source inside maybe a module, or does voltage source exist? What do you mean? What do you think? Tell
What do
me.
you mean by that voltage source exists?
I mean that say you have a DC-DC buck module. So do you have a voltage source within the module or not?
No.
I mean, it should be just a place to just input the voltage source, not
Yeah.
exactly on
So
the board.
so that's kind of a placeholder, right? So that's basically two input ports which has a ground and a voltage in, or maybe some kind of voltage values. One is a reference, one is a higher potential, right? So there are inductor, switches, diode, capacitor, and load resistance, right? Hello. I
Yep.
need
Yes.
this to be
Yeah.
interactive. I'm sorry.
Yeah.
ठीक है. So is this switch a normal switch or some kind of complex switch? Okay, wait. Who is from electrical here? Okay. How many of you guys know about this DC-DC buck converter? Okay, so no one knows about DC-DC buck converter, right? ठीक है. Buck converter means uh, when you are input, when you are like giving an input of say DC 5 volt and the output is lower than 5 volt, it is called buck operation on DC, which means that you are basically stepping down the voltage, the input voltage of the DC input to a much lower voltage in your load. Okay. Now what happens is uh, there are different types of buck modules. There are complex modules, maybe a
I'm sorry to
particular I.
interrupt.
Huh? Yeah.
Uh, did you say we are stepping down? Matlab, is it something related to clamping?
No, it is something related to pulse wave. It is basically averaging out the output of like DC input so that, okay, let me give you an easier example. Say there is a digital signal high and low, which, okay, do you know duty cycle?
Yeah.
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 Yes.
So say, for example, there is a 5 volt VCC DC signal source, which is operating at a duty cycle of 0.5. So what will be the output voltage states?
2.5 volt almost.
What will be the not average? I told the output voltage states.
5 and 0.
Yes. So 0 is for digital 0 and 5 volt is for digital 1. Right. So if the duty cycle is 0.5, what is the average voltage of the output?
For 50%, 2.5.
Yeah. Sorry.
2.5 for 50%. Yeah.
So 50% of 5 volts, like 2.5 volt, right? So what happens is if we are doing this blankly using some kind of a DC step generator, neither that would be so much of straightforward, and it will also cause an interrupted signal to the module or maybe the circuit we are in like inputting. Okay, so what it can happen, say your microcontroller is using 3.3 volts and your input is 5 volt, so you are using some kind of a DC voltage signal and some kind of duty cycle generator. Okay, so if the ratio is 3.3 by 5 for the duty signal, that may give an output for a time period, but what the MCU sees, say your clock duration is 1 second. So what will happen? The MCU will be turned on for like 3.3 by 5 part of the whole time period, like of 1 second, and it will get turned off simply, right? So that's basically turning a MCU on and off each second. So that doesn't make any sense. So when you are doing this same thing in a much higher uh, like frequency, this won't change anything for the MCU, right? The MCU will basically turn on and off at a very high frequency. So what we do, we add some kind of passive energy conserving components like inductor and capacitor, so that if we are, even if we are doing this kind of switching operation inside this circuit, we won't be having like we won't be seeing this kind of like on off operation on the output. Understood? Understandable? Anyone?
Yeah.
Yeah.
सो आई एम सॉरी, या सो क्या होता है कि ये इंडक्टर एंड कैपेसिटर रहने के वजह से मेरा जो आउटपुट है, आउटपुट लाइक लोड, ठीक है, लोड विल सी कि हमारा जो आउटपुट वोल्टेज है दैट्स काइंड ऑफ अ कंटिन्यूअस, ठीक है, विच इज बेसिकली द एवरेज डन बाय द ड्यूटी साइकिल एंड ब्ला, ठीक है। तो क्या होता है, इसीलिए हम ये सिंपल सर्किट, इसको बहुत कॉम्प्लेक्स वे में बनाया जा सकता है। देयर आर मल्टीपल वेज, देयर आर मल्टीपल स्मॉल कंपोनेंट्स, बट छोड़ो वो सब। We are not using any kind of a IC like buck IC in here. We are just using inductor, diode, capacitor and resistor, ठीक है। So let's get back to the circuit. Keep in mind what was the circuit, याद है?
Yep.
दिख रहा है ये यहाँ पे? आई एम यूजिंग दिस साइड बार्स नेम्ड components, manufacturer parts. Are you able to see that? Like these are opening for me. Are you able to see these are opening?
No, no, not the explorer and manufacturing wala part.
Yes, they.
It's there in the panels, I think. If I clicked,
Yeah,
it was not showing for me, but then on clicking on panels, it's showing.
yeah, I mean, I am clicking and the menu is getting opened. Are you able to see, or should I change from window share to screen share?
No, no, it's completely
आपका
visible.
सीन दिख रहा है.
हाँ, sorry,
It's fine from you. Like we can see it.
Yeah, it's visible.
it's visible, right? ठीक है. Okay, so what we will do, we will first select an inductor, है ना? Now, inductor, there are multiple types of inductor, right? See, you will be able to see all those details in here. When you are selecting one, the diagrams will be shown in here. The okay, यहाँ पे दिख जाएगा, यहाँ पे 3D मॉडल्स दिख जाता है. These are basically chip inductors. Are you able to see?
Yeah.
Yeah, obviously, try to do that by yourself as well.
Like, I cannot view the same option as you are able to. I cannot view the same options that you are able to view.
Yeah, okay. So how to do that? Go to the details. Basically, the details will be in here. Go to the details. Now, when you will scroll down, there will be models which are hidden. You can just unhide the models and you can see that those parts.
Also, I cannot select the inductor, like the first inductor 21 in the bracket that you can select.
Which one? The first one?
Like,
Radial inductor?
yeah, the first, no, 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 like above that it's written inductors and in the bracket it's 21. Like just below the component. Yeah, that's it.
Oh, okay. So you don't have those libraries. ठीक है. Let's switch to the Explorer. Let me see if you guys have this. I am going to. Okay, visible now.
I cannot even see the Explorer. Like it's not in like my sidebar.
Go to the
Sure.
Explorer and
Array,
search.
at bottom right there is a thing panels. Na click that. Like I think I was facing the same problem. Like click
Okay,
on the panels, you
you are
see all
not
these
getting
panels.
the Explorer option, or are you not getting the like Inductor 21 those stuff?
I was not getting both. Like I clicked on Explorer from the panel that Siddharth told, but it's telling to activate Altium 365 something. I'm trying to do that.
अच्छा 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 ठीक
Yeah,
है.
same for me.
Can you create a workspace? Can you guys create a workspace in here? Basically, this this button will show like not connected, something like that. So okay, someone needs to
Yeah,
share.
same.
Someone else needs to share their screen so that I can guide you.
Hello, sharing.
Yeah, so there is a, yeah, not connected button there.
Take a minute, I'm activating the workspace.
Hello.
1 second. Ah, I'm there. I'm just activating the workspace. Hello, can you hear me?
What happened?
1 second, I'll share my entire screen. Give me a second.
Your laptop has been freezed, I guess.
Just give me. No, it's not freezed. Just give me. The thing is, you minimize this thing, right? So
Okay.
wait, I'll share my entire screen, Sandeep.
Yeah,
I
okay.
shared only
Yeah,
the
I
Teams. I'll share my entire screen. One.
Okay, it's better
I
you
guess
do the stuff once
I
again.
created the workspace, I think.
Yeah,
Like
you
I
have to
connect
basically
I
do that. Pratik?
uh
Yeah.
So you can take control of my this thing.
Nah, you just do it because I can't even see. Yeah, visible now. Okay, go to the not connected
hmm.
button beside your my account button.
Yeah, it's
Yeah.
connecting. It's connecting.
Okay, we can't basically see it
Oh,
as
it's
that's a new
connected.
window, right?
I shared my entire screen. I think it should be visible.
Basically, share your entire screen to show others.
I am.
Anyone else yet to do that? Hello.
No, I think connected. Like, connected.
Sorry.
No, I think we connected like that workspace wali thing.
Everyone got connected?
I'm still doing it.
Nope, just me.
Okay, my bad. Yeah. Okay, I was disconnected from the LAN for such a long time. Okay. Yeah, so everyone got connected, right?
Nope, I am having a issue. But it's showing that but it's
Yeah.
showing access violation.
Let me so
So,
let me see that. Okay, good.
can you see that?
Hmm. Visible. Close that. Uh, Close Altium and restart.
Okay.
Maybe if that works. Let's just wait until Sujal does his stuff.
Hello, can you hear me?
Yeah.
My internet went out for a while, so should I share my screen again once more?
Yes, I think everyone has done that. Vinay, Udipto, Mushid, Siddharth,
Yeah, mine is working.
Yeah,
Ayush.
mine is done.
Mine is done.
Okay,
Yeah, mine is done.
Ayush doesn't have. Okay. Mm.
So should I just log off and log in again? Will that work?
I think that would be a better option. Yeah, just sign in here. Now close this one. Close the Explorer.
So I'll open it again.
Yeah. I mean, just first connect it. No. Are connect it, man.
From where?
There is one option with your name, right? There is a workspace with your name. Inside the not connected button.
Okay.
Within the not connected button. Yeah. No, it's yet not connected, man.
If it's not working.
Ah, it is not working. Mm, no. Don't just click on that button repeatedly. What you can do is just close Altium and restart.
Okay. Can I try to make a new project? तब connect होगा क्या?
I don't think so.
अच्छा,
Close
I will let you
Altium,
know.
restart. Hmm. I think there is
क्लिक ऑन
issue.
योर अवतार टॉप राइट में जो नॉट कनेक्टेड के बगल में you are already connected with this custom connection. ओके ये उसमें चल जाएगा कैंपस का। I'll leave it. We don't have all this information. एक्सप्लोरर बेसिकली ओपन नहीं हो रहा ना।
नहीं हो रहा है इसका। Okay, just use the substitute the manufacturer part search for now. ठीक है।
अच्छा, आई कैन यूज अ जनरल मतलब इंडक्टर वगैरह पार्ट वो तो यूज कर सकते कंपोनेंट से।
अगर उसका कोई मॉडल नहीं हो तो यू कांट पीसीबी डिजाइन।
दिस वन
यू कांट पीसीबी डिजाइन।
मैन्युफैक्चरिंग में फिर you don't have the exact induction value and
डिटेल्स।
all.
आई एम टेकिंग the charge again. So basically, I will be using manufacturer part for him. It's a passive component, right?
जैसे components में you can use Sujal, वही use कर लो. For now it's fine. We're not going to manufacture right now.
ठीक।
So can everyone see that?
Actually, can you
Hello.
explain how you got to manufacture parts? Or
Okay, so go to the panel, go to the manufacturer search part, and you will get that.
oh, okay, got it.
ठीक है?
Yeah.
So there are many types, many structures, many packages. There are different data sheets from different distributors. There are alternatives. Okay. So what you can do is just parameters, show more, and you can just see that what this inductor is, what is the construction, code material, inductance value, ठीक operating range, maybe number of pins, functions, packaging. There are many details. Understandable. So you have to choose your inductor in such a way that the inductor doesn't self resonate. There's a new term I know. Let me tell you, no inductor is absolute. So every inductor has its own capacitance and sorry resistance values. ठीक है? Like see, for example, here there is a DC resistance of 1.6 R, which means 1.6 ohms. ठीक है? Any speakers or maybe any kind of coils are made of mostly wires, right? So there must be some kind of wire resistance inside that. So you can see in, say, if I select this one, okay, you will be able to see that there is a coil inside which is exposed. Basically, what happens is when we are using this kind of copper exposed coils, will be like the coppers will be coated with maybe some kind of insulating materials that is heat and also moisture um, like resistance. ठीक है? So what you have to do is first make your circuit and decide your components. Okay. So what will be your specification of the circuit? What will be the operating range, temperature operating range of the circuit? Okay. If you are working in this range, well and good, use that. Okay. So you have to keep in mind that all kind of circuits, electric circuits, have heating problems. Basically, this kind of power converter modules, okay, because they are using high frequency conversion, right? So they are having some high current input or maybe high voltage input, okay, and like so frequent switching of MOS or maybe energy from one energy storing component to another may lead to heating up of the wire in between them. ठीक है, तो इन सब वजह से the buck modules or maybe the boost modules are more prone to heating up. क्या होता है फोन में, क्या होता है फोन का इनपुट बेसिकली 5 volts, maybe 9 volts or maybe 12 volts. ठीक है, like higher wattage chargers are capable of 12 volts output. ठीक है. So what happens is जब ऐसे मॉड्यूल्स हम बना रहे हैं, फोन में भी ऐसे मॉड्यूल्स है, दे आर मच कॉम्प्लेक्स, दे आर विद इन अ चिप. बट अगर हम ऐसे मॉड्यूल बना रहे हैं फॉर आवर लाइक मैक्रो डिजाइन, बड़े बड़े चीजों के लिए हम बना रहे हैं, तो हमें ऐसे बड़े ऑब्जेक्ट्स जैसे बड़े इंडक्टर्स चाहिए होंगे. ठीक है, तो यू हैव टू फर्स्ट डिफाइन कि हमारा इंडक्टेंस क्या है, इंडक्टेंस का नंबर ऑफ पिंस क्या होगा, ऑपरेटिंग रेंज क्या होगा. ठीक है, मे बी कवर्ड होगा या अनकवर्ड होगा डिपेंडिंग अपॉन योर आईपी रेटिंग. डू यू नो व्हाट इज आईपी रेटिंग? एनीवन?
Like
IP
the
isn't like how
beautiful,
much waterproof it is.
like I heard like 64 होता है splash proof होता है, like 67 means like you can wash,
Yeah,
something similar.
waterproof.
So this means it means that international protection code. There are 2, maybe 3 or 4 digits of IP rating. So basically the first one is maybe the water protection, second one is dust protection. ठीक है, ऐसे होता है. So if you are making this water protected or maybe dust protected, ठीक है, you will be using this kind of packaged modules which has like no input, like there are no entrance path for dust or water. ठीक है, so ये सब हम यूज कर सकते हैं. मे बी व्हाट यू कैन इम्पोर्टेंट थिंग कि हमारा जो बक मॉड्यूल रहेगा, बक मॉड्यूल का खुद का एक फ्रीक्वेंसी रहता है. ठीक है, सो व्हाट आई वांट टू रेफर व्हाट आई वाज टेलिंग बिफोर कि हर एक इंडक्टर का खुद का एक कैपेसिटेंस वैल्यू, खुद का एक रेजिस्टेंस वैल्यू होता है. सो एट ए टाइम एन इंडक्टर विल वर्क एज अ आरएलसी सीरीज सर्किट. ठीक है, तो क्या होता है कभी कभार व्हेन द कैपेसिटेंस and inductance values are such that the operating or maybe the resonant frequency for that RLC series circuit is near to your operating range. ठीक है, तब क्या हो सकता है? बताओ बताओ.
Sorry, could you repeat the question?
मैं बोल रहा था कि say for example you are going to operate your DC buck module at a temperature, sorry, सोच लो at a temperature of 0 to 100 degrees Celsius. Maybe the operating frequency is like 1 megahertz. तो क्या हो सकता है? For this particular inductor that I am pointing it.
It can melt due to overheating.
It can melt due to overheating. Why?
The rating on this is minus 20 to 80, and since the test frequency is 100 kilohertz, due to that rapid varying of frequency could probably melt.
Nah, that's not the case. So the thing is, when an inductor has a frequency of maybe like self-resonating frequency, say of let for example 100 kilohertz. Okay, what will it happen? It will be self-resonating. Matlab, the inductor will work as a LC resonator. ठीक है, that will basically trap amount of energy inside that, and it won't work as intended. ठीक है, so that is kind of a loss for a buck module. Okay, let's not go to those kind of details. अभी जो हम देख रहे हैं कि हमें देखना है for the lowest loss, higher operating temperature range, low tolerance, higher frequency operation, maybe the closed packaging, ठीक है, low DC resistance, DC series resistance, and etc. ठीक है, ferrite, mostly core material ferrite ही होता है because that's cheap. तो yeah, so we are using this now. ये हमारे पास है नहीं because this is showing up. ये हमारे लिस्ट में है ही नहीं. So what will we be doing? We'll be saving it inside our components list, inside the inductor. Now I need to just switch 1 second. You guys are following me, right?
Yeah.
So जब मैं यहाँ से ये सेव बटन दबाऊंगा, there will be a option for create new component inside your component list. ठीक है, which we will be doing to save that, and now we'll save all the details. ठीक है, सारे डिटेल्स हम इसमें सेव करेंगे so that we have all the like details for the particular component. ठीक है, now okay. Yeah, now inside the component we have this. We have this particular part. Okay, do you know guys what this means? Okay, I forgot to show you. Yeah, there is 12 SPNs. Any guess what does
Specifications.
SPN?
Are they like Made by different companies, same thing.
Distributors mainly.
Okay.
So you know, like Mauser, DigiKey, Avnet, Ado Electronics. Okay, you may not know these things, but you know Mauser and DigiKey, right?
Yeah.
So basically, what they do is, hmm, so they are the distributors, right? So you can just make this stuff inside your design. ठीक है? So ये आ गया यहाँ पे टाइप इंडक्टर, ठीक है, आ गया. So now we will be saving it to server. Component descriptions not specified. Yeah, so there is an error related to it. है ना? And now this have yes, saving it now. Hello.
Sorry, I'm still getting that error.
Mm-hmm.
I'm still getting that error. Component list not specified. Validation
You can add
detected.
any name and description about it, to be honest.
Sorry.
Now, Dipto,
Yeah,
you can, like, when you will go to the left panel, right, and
yeah.
see which component you are talking about, you'll see that there is nothing written in the name and the description. For example, सौम्यदीप आप जो पहला वाला दिखाए थे वो कर सकते हो क्या? दो आपने ये निकाले थे फॉर्म का डॉक. वन
Mm-hmm.
हैड नेम, वन डिडंट हैड नेम. अभी आप जो सेव किए वो एग्जैक्टली खोल सकते हो फिर से लेफ्ट साइड पैनल से.
Ah, that has been saved now. Okay,
ले-
I'm doing it
या फिर से.
once again. इंडक्टर होने के बाद
हाँ, basically now you can see कि there is no name and description written. कंपोनेंट वाला इसके पीछे वाला में. नॉट दिस वन, नॉट यूज कंपोनेंट डेटा, उसके पीछे वाला जो लेफ्ट पैनल के जस्ट बगल में है उसमें नेम एंड डिस्क्रिप्शन इज नॉट रिटन. तो
that's
उसके वजह
select.
से इशू हो रहा है.
So what you will have to do, you have to select everything and then press OK, so that you are updating those details inside. ठीक है?
ऐसा में जो उसका बात कर रहा है जो पीछे आपके हैं
हाँ,
ये वाला, ये ठीक है.
that's not accessible. That's not accessible basically.
अच्छा.
ये जब मैं ओके करूंगा तब यहाँ पे
ऑटोमेटिकली आ रहा है.
ये जो नेम्स नहीं थे ये नेम्स आ जाएंगे. ठीक है?
सौम्यदीप आ रहा है क्या? सौम्यदीप बोलो, सॉरी उदित. तो
Actually, I did not understand what I'm supposed to do.
ठीक है.
Like
So
I'm on
basically
this
I'll
screen.
explain.
अच्छा.
एक बार स्क्रीन शेयर ही कर दो ना, बेस्ट रहेगा.
हाँ हाँ.
वही बोला मैं.
Yeah, is it?
I know it's boring for you guys. हाँ, ठीक है. हो गया ना, ये तो सेव हो गया है.
नहीं, पर when
Okay,
I click on save
you
to
haven't
server.
okay, you haven't selected a type. See, there is a type none. You have to select a type for it.
Oh,
Yeah,
okay.
that's
Inductor.
inductor, right? Ha.
Okay,
Now
and
you can
now
save to server.
still.
Wait. Yeah. Cancel.
See?
Component folder path not specified for that. Close it.
एडवांस सेटिंग में फोल्डर
एडवांस में फोल्डर नहीं है.
Oh, acha, here, okay. Uh, do I select component?
कंपोनेंट्स के अंदर है इंडक्टर. इंडक्टर्स ऊपर है. हाँ.
ओके
डबल क्लिक.
सबसे नीचे हो
डबल क्लिक. हाँ.
I'm double clipping, nothing is happening.
डबल क्लिक नहीं है नीचे
ठीक है.
Oh,
और
acha,
ओके
there
लिखा
is
हुआ
an okay.
हाँ. Now it's yeah. Okay.
Acha. Acha, one question, when you were sharing your screen, you did not separately select these, did you?
Sorry. Acha. For that thing, I had selected at first, na. I had selected inductor at first. But you
Oh,
had
okay, I must have missed that. Okay, makes
yeah.
sense. Thank you.
I can show it again if you want.
I get it, I should have. No, yeah.
Now, if you go to save, there is an option for create new. When you select on inductor and press OK.
So it's not the entire screen. एक विंडो बस आपका शेयर है.
Okay, sorry. Yeah, let me do that again for you guys. Inductors. Now, okay, वो हो गया हमारा फोल्डर. ठीक है. Now, if I select all, this will be getting inside this one. ठीक है. You have to select the models as well and data sheets as well. ठीक है. हो गया. सबको समझ आ रहा है.
Yeah.
Yes.
Now this new component will be made with this. Now you can save to server. I'm just discarding because I have created 3 such things. हो गया. Now you will be able to find the same component in here. ठीक है. जब तुम इंडक्टर पे आओगे, what was the name? This one, right?
Yep, वही है.
Okay, I have placed it. Sorry. तो ये जब सिलेक्ट करोगे इसके अंदर सब कुछ है. ये सब इंपोर्ट हो गया. यू कैन सी दैट, राइट? नाउ द फन थिंग. अब हम क्या करेंगे? वी विल इंपोर्ट. ड्रैग एंड ड्रॉप. हो गया. दिख रहा है सबको? Now you can go to properties and you can just see that there is description regarding this. You can name it. You can change the angle. ठीक है, you can change the footprint. If there are multiple models, you can change the footprint. I'm just telling. Okay, there are also options for showing the details. Pins 1 and 2. ठीक है, हो गया. Now for same for the so same for capacitor. We are going to select a capacitor. Anyone knows what is the difference between this packaging? Say I'm using this one. ठीक है, Panasonic का aluminium electrolytic capacitor है, which has the operating range of -40 to 85 degrees Celsius. Will that work? Because इसका ज्यादा है. याद है इसका प्रॉपर्टीज? हेलो हेलो, am I connected?
Yes.
Yeah.
तो इसका मैक्सिमम ऑपरेटिंग टेम्परेचर इज 125 डिग्रीज ना. So we must find some capacitor which has a working temperature of more than 100. ठीक है, so I found one. This is the tantalum capacitor. ESR, this is a very important thing you need to know. Like inductor have their own the series resistance. Capacitances also have their own resistance value. Okay. ESR means electrostatic series resistance, which is basically leakage of current inside a capacitor. When this leakage current gets too high, the capacitor gets shorted and it gets burned, blown away basically. ठीक है. This is a surface mounted 2-pin capacitor which is capable of a current of 463 milliamps and the value is 100 micro. Voltage rating is 10 volts, so you can't give a voltage difference of more than 10 volts across this. ठीक है. I'm just taking this just as an example. As because I had used components for taking the capacitor, I can just drag and drop. But if you are using the manufacturer part for that, you are unable, because these are not inside your components list. ठीक है. So if I want this to just drag and drop this one, this won't show up. You can see that, right?
Yeah.
Yeah, so some basic tricks when you are holding this um, like part and pressing shift, sorry, space bar, you will be turning your device. When you are pressing shift plus space bar, you will be turning it clockwise. Okay. This can also be done differently, but okay. Now tell me what things are left.
A diode,
Hello.
capacitor, diode, and a resistance. The diode.
Diode. Is resistance inside the circuit or outside the circuit?
No, it's a component, that exterior part जिसको provide कर रहा है.
So basically the resistance is for the load that we are connecting at the output side. Okay? Everyone understanding? Hello.
Yeah.
And what about the switch? What about the switch? Is that a basic on-off switch?
No.
What is that? What is it? Any guess? Anyone? Hello? Am I audible?
Yep, you are audible.
So tell me what kind of switch it is.
नहीं पता तो नो बोल दो यार तुम लोग.
No, I don't have any idea about the types of
No.
switch that you use.
Yeah, right.
I basically told at the first, ki we can't use any kind of switch because that's a controlled switch, right?
अच्छा, हाँ.
So control switch के लिए हम क्या यूज कर सकते हैं, मतलब हाथ से तो नहीं कर रहे हैं switch. What else among the electric components are used as a switch? Tell me. This is the easy thing.
Transistor.
Transistors. So how are we doing that?
मतलब it has 3 poles, and depending upon the voltage on each, it may get on and off.
तो यहाँ पे हम कैसे करेंगे? There will be some kind of pulse generator, right?
Yeah.
So we need a pulse generator and a MOSFET switch. Why not BJT? ठीक है, BJT पे नहीं जाते हैं. MOSFETs are used for high powered applications. ठीक है. चलो. So we have this capacitor in here. We need a MOSFET. So we'll be using something like this, but not so big, because you can see like they are capable of 12 amps. such a large current. We don't need. We can use this one. बताओ 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 बताओ. Fast.
No, I don't think that we will be using 60 volt.
ठीक है, overestimating is okay. We are not using low high current ones, ठीक है, because they will be costly, plus they will be having greater क्या बोलते हैं लॉस. ठीक है, पीसीबी का जो लेआउट है, लेआउट में भी उसका बहुत ज्यादा आउटपुट होगा. ठीक है, साइज भी बहुत ज्यादा होगा. सो वी कैन
So
यूज
how much
दिस.
is high current?
हाउ मच इज हाई करेंट? गुड क्वेश्चन. हमारा जो सर्किट होगा, हमारा जो एप्लीकेशन होगा, एप्लीकेशन के बेसिस पे डिपेंड करता है. बेसिकली एनीथिंग मोर देन 1 amps इज कंसिडर्ड एज हाई करंट. ठीक है, सो either we can use the 60 volt or maybe we can use this 20 volt one. ठीक है, but being on the safe side हम लोग ये 300 मिली एम्प्स वाला यूज कर सकते हैं वर्ड से. ठीक है, जस्ट ए बेसिक क्वेश्चन. हम मॉसफेट यूज करते हैं ताकि उसका जो सीरीज रेजिस्टेंस है, सीरीज रेजिस्टेंस भी ज्यादा हो, उसका लॉस भी कम हो थोड़ा. ठीक है, so yeah, we are using this. Basically this can be digitally controlled. ठीक है, इसीलिए हम मॉस यूज कर रहे हैं. अगर हम लोग चाहते हैं कि करंट कंट्रोल करेंगे तो वी कैन यूज बीजेटी एज वेल. नाउ टाइम टू कनेक्ट दिस स्टफ. ये दिख रहा है प्लेस वायर.
हाँ.
We'll be connecting okay. If you want to end a connection you can just use the escape button. ठीक है, बताओ क्या रह गया, क्या कौन सा कंपोनेंट रह गया इसमें.
Us.
अभी तक
डायोड.
डायोड डायोड नहीं लगा है ना हम लोग.
डायोड और इनपुट फॉर वोल्टेज सोर्स.
हाँ, तो इनपुट वोल्टेज सोर्स यहाँ पे नहीं रहेगा. क्यों? मैंने बताया है इसके
Maybe
पहले.
we are just creating that module.
ठीक है, उस एक बक मॉड्यूल का क्या रहता है, इनपुट 2 पोर्ट्स 2 पिंस, आउटपुट के 2 पिंस, है ना.
Yeah.
सो हम क्या कर रहे हैं, हमारा इनपुट के 2 पिंस हो गए यहाँ. what we can add is we can add a, say for example, ठीक है, ये इसमें है ही नहीं, ट्रांजिस्टर के अंदर हम मैं क्यों देख रहा हूँ. anyone of you know what is a screw terminal block?
No.
It's like you screw down on it such that you put a wire, you screw on it such that the between the two contacts, so that you can use it to wire it in through.
Yes. तो बेसिकली दिस इज अ स्क्रू टर्मिनल ब्लॉक, ठीक है। ये बहुत जगह में दिखने को मिलेगा, एंड सो एज इट इज नॉट इनसाइड द कंपोनेंट्स विल बी इंपोर्टिंग दिस।
वो इस कैपेसिटर्स हटा दो फिल्टर में से।
अच्छा, हाँ सॉरी। ठीक है, अवेलेबल नहीं लग रहा है।
एक बार कनेक्टर्स के अंदर चेक करो तो आप मिल जाएगा शायद। कनेक्टर में बैटरी कनेक्टर्स मे बी।
यस,
हाँ मिल गया।
मटेरियल, दैट्स वियर्ड ना। ठीक है, दैट्स
आप मिस
बेसिकली।
कर गए, ऊपर था एक मिस कर गया आप, थोड़ा ऊपर था। ओके 3 इनपुट है ये
या
लेकिन।
तो बेसिकली अंडरस्टैंडेबल, काइंड ऑफ अंडरस्टैंडेबल। लेट मी सर्च बाय टर्मिनल ब्लॉक।
Actually, which MOSFET are we using? Can you please repeat that? I kind of missed that part.
Okay, just you can use any MOSFET with like less current maybe.
Like in
अभी
what
के लिए
way?
लेस करंट, बाद में हम मोर करंट पे आएंगे। सो जस्ट फॉर नाउ क्या है, क्या आ रहा है?
एक्सटर्नल पैकेज डाउनलोड कर लो ना आप।
ना ना ठीक है, आई हैव गॉट समथिंग।
हाँ
या
मिल गया।
सो दिस इज अ screw terminal block that I was telling. कनेक्टर्स कहाँ पे है यहाँ पे? Okay, my internet is slow a bit. Until that, uh, we can just select a diode. We can't choose random, ठीक है? we can't even choose this one. Any guess? What does ESD
It-
protection means? ESD means electrostatic discharge. What we can't use because that's for like, say I'm in bare hands, a capacitor is charged and I have touched the output terminal. ठीक है, क्या हो सकता है? A huge current can go from the capacitor through all the components to my body, maybe to the ground, है ना?
Yeah.
So this circuit protects from such a high spike of current, or maybe there can be a case where my body has some electrostatic charge and that charge gets flowed into the circuit. Okay? So this also prevents that. Yeah, so basically we can use this one. Okay? ना टाइम ले रहा है. ठीक है. There's kind of some kind of issue maybe. Okay. Yeah, so just beer for this stuff to be done. This is going on, man. अरे, ठीक है. So uh, so basically you can see that, right?
Yeah.
This connection is blocked. हाँ, ठीक है. So this is the basically the connection and हम लोग क्या करेंगे, अभी डालेंगे connectors. ये सब कनेक्टर्स तुम लोग शायद देखे हो. These are for batteries maybe. Uh, the thing that happened कि ये शायद सिलेक्ट सेव हुआ नहीं है. Let me do that 1 second. ठीक है, there is some problem related to this. ठीक है, done. So now ये मिल गया. ये अब हम लगा सकते हैं ऐसे. ठीक है, ये सेम चीज हम एक दूसरा लाके इधर भी डाल सकते हैं, है ना. तुम सब कर रहे हो ना मेरे साथ, ये जो भी मैं कर रहा हूँ.
Yes.
तो दिस इज आवर बेसिक स्ट्रक्चर, है ना. हाँ, सो बेसिकली आई थिंक काफी टाइम हो गया है आज. आज के लिए इतना ही सोच लो. ठीक है, आई वोंट बी कंटिन्यूइंग टुडे. कल थोड़ा कर सकते हैं. या हो गया. इट इज शॉर्ट हो गया. चलो, हाँ, बिल ऑफ मटेरियल्स के बारे में मैं बताऊंगा थोड़ा सा. जब हम ये सेव करेंगे एक शीट, उसके बाद देयर विल बी ऑप्शन फॉर बिल ऑफ मटेरियल्स यहाँ पे. या फिर अगर तुम लोग खुद से बना रहे हो ये भी सही है. या फिर इधर एक ऑप्शन मिल जाएगा एक्टिव बीओएम नाम का. मिल रहा है क्या कहीं किसी को?
Which
हेलो.
option?
यहाँ पे ये लेफ्ट वाला जो एक्सप्लोरर है, यहाँ पे एक्टिव बीओएम नाम का एक ऑप्शन आने के चांसेस है. यहाँ पे आईएनआर करके ये रियल टाइम में कर सकते हैं हम, ताकि रियल टाइम में ये बीओएम बने. हाँ, बीओएम में काफी प्रॉब्लम्स आ सकते हैं, जैसे कि जब हम लोग नेम्स नहीं डालेंगे तब ये दिक्कत कर सकता है, जैसे कि हमें दिख रहा है कि ये जो है, इसका नेम अगर मैं कुछ डालता हूँ J1, ठीक है, जो भी हो, ये सब प्रॉब्लम्स आएंगे, ये सब हम कल सॉल्व करेंगे। ओके, सभी को समझ आया आज जितना भी हुआ?
Yeah.
Yes,
हाँ
but like, can we simulate it or something?
क्या?
Like, can we simulate it or
हाँ, हम यहाँ
स्कीमेटिक्स
पे
नॉर्मली सिमुलेट नहीं होती है ना स्वामी जी।
हम सिमुलेट कर सकते हैं, पर द थिंग इज, अभी के लिए हमें यहाँ पे ये वाला जो ऑप्शन है, यहाँ से हम वोल्टेज सोर्स लगा सकते हैं यहाँ पे। एंड यहाँ पे ही अगर तुम ये जो एरो है, इस एरो को अगर थोड़ा क्लिक करके रखोगे तो देयर विल बी वोल्टेज प्रोब। ठीक है, तो ये वोल्टेज प्रोब लगा के तुम आउटपुट वोल्टेज भी देख सकते हो। बट द प्रॉब्लम इज, हमारा ये जो मॉसफेट है, मॉसफेट के लिए कोई ड्राइवर चाहिए होगा, है ना, पल्स जनरेटर चाहिए होगा। तो
एक
हमें ये,
मिनट स्वामी जी,
हाँ,
आई ऑलरेडी हैव सिमुलेशन ऑन एलटी स्पाइस, वो दिखा सकते हैं।
दिखा सकते हैं हम, पर यहाँ पे ये पल्स जनरेटर सर्च करना होगा तुम्हारा टास्क। कर पाओगे? हेलो?
like, will it be in the component list?
वो मैं क्यों बताऊंगा, वो तुम्हें, तुम्हारा होमवर्क है। मैं आधा चीज दिखा भी दिया वैसे। ठीक है, आ, प्रणव क्या बोलता है, आधा चीज मैंने इनको दिखा भी दिया। चलो ठीक है,
Yeah.
दैट विल बी योर टास्क बेसिकली, कि एक पल्स जनरेटर निकाल के यू विल हैव टू सेट देयर प्रॉपर्टीज एंड यू हैव टू सेट अप द होल सर्किट फॉर सिमुलेशन। ठीक है,
Okay.
प्रणव विल टेक ओवर फ्रॉम हियर। आज के लिए
Yep.
इतना ही।
Uh,
ऑल्टियम पे ये जो काम मैंने दिया करके आना, कल हम पूरा पीसीबी डिजाइनिंग अच्छे से सीखेंगे। ठीक है,
एक वन लास्ट थिंग जो अभी बोल रहे थे तुम लोग अबाउट सिमुलेशन, so this is a different software, LT Spice, if you guys would know about this. किस किसको LT Spice के बारे में पता है? What is the use of LT Spice? Okay, three. So basically, let me just brief you about this. This is more or less used for simulation of your circuits. ठीक है, simple circuit सब जो बनाते हैं using normal op amp वो सब चीज, then we make this. What is the use? ये जो मैंने सामने बनाया, this is not buck converter, but rather buck boost converter है पूरा। ठीक है, I'll not go into much of details, but एक चीज तुम लोगों को दिखा देता हूँ। So for this situation, this was like simulation of buck boost जो बनाया था, and I was concerned about the amount of fluctuation at the start. So for example, in this situation, let me, yeah. So as you can see, ki it is taking around 2 milliseconds to get stabilized. If I would change the values, let's just say Remove this. Just a second. Just a few things to add. For example, if I change some values, ठीक है, इसमें there is already like basic buck converter है, उसका boost है, और उसके बाद उसका ये whenever you will try to see the buck converter now, like raw buck converter which we talk about, that normally gives some ripples. वो ripples को भी मैंने यहाँ पे like remove किया था. So for this situation, let's just say it's not simulating, right? Okay. Let's just say कि I increase the inductor value 10 से 100 कर दिया, and then run the whole simulation again. तो यहाँ पे you guys can see there is a lot of ripple. दिख रहा है?
Yeah.
Yeah.
या तो ये सब चीज को भी हैंडल करना होता है इफ यू आर टॉकिंग अबाउट बक कन्वर्टर या फिर पावर ट्रेन कन्वर्टर, वोल्टेज रेगुलेटर, जो सब चीज होता है. ठीक है. तो like thankfully I had this same thing which we talked about today. So this will come out if you simulate the whole thing. बात रहा when we'll be talking about like this is something LT spice में you don't normally get oscillator. तो in this situation इसको मैंने pulse wave दिया था with a very short amount of time. यहाँ पे period you can see the panel independent voltage source. दिख रहा है क्या तुम लोगों को?
Yeah.
हाँ हाँ.
Okay, so उसमें you can see कि there is 50 micro ohm time period, microseconds. इस दिख रहा है हाईलाइट जो कर रहा हूँ?
No, it's not fully visible.
Okay, एक सेकंड. Right, so entire screen works. Now you can see, right?
Yeah.
So यहाँ पे you can see कि 20 microseconds है. This was used in this software as oscillator, and either if I right click, I can change the values of inductor and all. So for this example, like you can see कि I can easily change the values of L1, C1, C2. Normally manufacturing parts रहेंगे. So in case of manufacturing part, for example, ये diode एक manufacturing part है. I will have to pick a diode out of like the library which is inside this. For example, ये जो diode मैंने use किया था उसका breakdown voltage was pretty high, क्योंकि normal diode, I don't want current to flow in reverse bias. Breakdown voltage इस case में मैंने काफी high रखा था. If I would have tried to use a Zener diode, उसका breakdown voltage में around 10 volt या 6.2 volt वैसा कुछ डालता. So these are like something. LT spice normally तुम लोग को use नहीं करना पड़ेगा, but in case if you would like to, you can see a few things. इसके बारे में tutorials वगैरह होता है. ठीक है. Even the amount of time I want to simulate this bar graph बना वो कितना duration का होगा. So yeah, you can see कि 1.5 microsecond में it is stabilizing. तो ये सब चीज देख सकते हो. This is one thing. Another Daniel, are you there? Uh, आप आज ये कंटिन्यू करोगे स्लाइड्स? हाँ.
Are you guys tired? I mean, it won't take much time. Hello.
I'm kind of tired today.
Yeah, I guess we can have to do. It's not that. It's yeah, it's just a term. And like this, this thing. Are you guys familiar with the nomenclatures of PCB designing?
No.
Okay. Yeah, then we can continue sometime.
Okay, anyways, then we will continue tomorrow also. ठीक है, PCB design का आज you guys saw, like, we didn't use any IC today. कल probably सौम्यदीप, can we tell them how to use ICs? Data sheet पढ़ना.
सभी को शायद डेटा शीट पढ़ना शायद सिखा दिया था तुम लोगों को, आई गेस।
Did you guys
माइक्रो
see
कंट्रोलर,
the
माइक्रो प्रोसेसर
Arduino?
के ऊपर जिस दिन हम लोग
Arduino का
माइक्रो
आप देखे थे ना?
कंट्रोलर एंड माइक्रो प्रोसेसर का किए थे, उस दिन शायद मैंने बता दिया था शायद, है ना?
How many of you guys like completed that reading the 200-page data sheet?
अच्छा हाँ, देयर वाज अ होमवर्क।
ATM 32 मेगा का.
किसी ने नहीं किया क्या? है? अच्छा, इनका वो भी था, प्रोजेक्ट भी था। ठीक है, प्रोजेक्ट के बाद भी टाइम नहीं मिला, ये भूल गए।
Not completed, मतलब टोटल मतलब all 200 पेजेस नहीं कंप्लीट किया अभी तक।
ना मतलब ठीक है, पूरा पढ़ने को बोला भी नहीं था मैंने। मैं बोला था उसमें से इंपॉर्टेंट जो पार्ट्स है फॉर अ बेसिक स्पेसिफिकेशन लिस्ट, वो निकाल के मुझे दो। दैट वाज द होमवर्क।
Okay. Also, like, I have seen ki assignment submissions are getting lesser now. Initially, I was thinking ki I would give more, like, be more easy on this, but यार नहीं कर रहे हो तो that would cause an issue. आगे catch up करने में फिर दिक्कत होगा.
हाँ मतलब अगर
So
कोई किसी को कोई प्रॉब्लम हो रहा है तो बता दो कि हाँ दिस इज गोइंग टू मच फॉर मी, फॉर अस, ऐसा हम लोग कम कर देंगे। अगर आ, दिक्कत नहीं है तो क्यों नहीं कर रहे हो, वही मेरा क्वेश्चन।
I want to ask one thing. Are you guys like comfortable with the electrical aspects of this thing? Like, are there anyone who like? Is there anyone who found like the things they were taught today were basics for electrical background, but since there are many people from non-electrical or non-electronics, like I just wanted to know that if you guys are had that knowledge beforehand, or is it becoming tough for you guys to follow?
Today was not tough, but like someday are definitely like a lot of information to process. Like today was pretty chill.
हाँ, definitely.
So how many of you guys found today's one too much hectic? Honest opinion, मैं किसी को कुछ नहीं बोलूंगा।
Not hectic, but there was some problem with my software, so मतलब I was trying to deal with that. So
हाँ
most of the
ठीक है,
time I was trying to do that.
जिसको भी ऐसे प्रॉब्लम्स हैं रिलेटेड टू सॉफ्टवेयर, जस्ट कांटेक्ट मी आफ्टर दिस सेशन, या फिर कल सुबह दोपहर, ठीक है? आई विल बी
okay.
हेल्पिंग यू।
Even tomorrow we can, like, Ayush, if you want, we can have a different session on easy EDA on the same project.
Yeah,
हाँ
sure.
Were you चलेगा?
हाँ.
ठीक है, peace है. We can do that. After 5, मतलब let me know, preferably.
See, you guys were asking about if simulation can run. I would suggest like you guys like beforehand, before you design the PCB, what you guys should most probably do is have a simulation ready in, let's say, LT files, right? This files and Proteus. Proteus is the components. Proteus has the footprints as well. So you guys can run, check all the specifications that you need, and then you can find it in whatever software they're using. Personally, I use CAD, but here we're going for Altium, so you guys can learn. You guys can have to search it basically. So for simulation, you don't have to just worry like there won't be a software that let's say that contains every of the features that you require. So sometimes we have to like that's why many software provides such features like Proteus, if I remember correctly, enables you to export files so that you can tag and import into another PCB designing layout, and then you can just get the you can just directly start connecting the PCB. So similarly to that, it's more akin to like having different sets of like it's just think of it like a kitchen basically. You have your oven, you have your microwave, etc., etc. So it's more in terms of that.
Yeah, so what Daniel told is basically this key PCB designing on Proteus is quite easier, but the problem with Proteus will be like yeah, there are many problems related to Proteus. Okay, say that's not a professional one. That the Gerber file, the file which is being like sent to a particular PCB fabricating company will not be able to have or maybe create fine details of the PCB if they are using the Gerber file which is generated using the Proteus. ठीक है, क्योंकि उसका जो वो आउटपुट फाइल होता है ना, आउटपुट फाइल में काफी प्रॉब्लम्स रहते हैं, लाइक दैट इज नॉट लीनियर मे बी, लाइक कैसे समझाऊं कि एक फाइल होता है जैसे कि हमारा मैकेनिकल में होता है ना, मैकेनिकल में क्या होता है, अरे एक्सपोर्ट करने वाला प्रणव।
File.
हम्म,
गर्बर फाइल का आप बोल रहे हो क्या?
मैकेनिकल में अरे वो 3D प्रिंटिंग का जो
कैड।
फाइल होता है ना,
अच्छा,
STL file, STL file.
हाँ एसटीएल फाइल। हाँ, सो एसटीएल फाइल में जैसे होता है ना कि वहां पे स्लाइसिंग के ये सब डिटेल्स, ठीक है, बहुत कुछ रहता है उस फाइल में, है ना। इलेक्ट्रिकल में भी ऐसा फाइल जो हम एक्सपोर्ट करते हैं उसको जर्वर फाइल बोलते हैं, जिसमें ये पीसीबी डिजाइन कैसे होगा, कहाँ पे कितना कॉपर रहेगा, कितना खाली रहेगा, इंसुलेशन, ठीक है, सिल स्क्रीन, ये सब चीजें कितना रहेगा, कितना अमाउंट में रहेगा, ये सब कुछ बहुत डिटेल्स में रहता है। नाउ प्रोटियस में वो इतना अच्छे से नहीं बनता जितना कि ऑल्टियम में होता है, ठीक है। प्लस प्रोटियस में चेकिंग का ऑप्शन नहीं है कि इलेक्ट्रोमैग्नेटिक इंडक्शन का प्रॉब्लम्स आएगा या फिर सर्किट रिलेटेड इश्यूज और मे बी सम काइंड ऑफ रूल वायलेशन की लाइक क्रॉस ओवर हो रहा है, या फिर बहुत पास है दो लाइंस, या फिर बहुत पतला है विद रिस्पेक्ट टू द करंट इट इज कैरिंग, ठीक है। ये सब चीजें ऑल्टियम में चेक होता है, प्रोटियस में नहीं होता। सो दैट इज द एडवांटेज ऑफ यूजिंग ऑल्टियम। हाँ, आई कैन अंडरस्टैंड कि इसका जो क्या बोलते हैं इंटरफेस इज अ बिट नॉट फ्रेंडली फॉर बिगिनर्स, बट हाँ दैट्स क्वाइट प्रोफेशनल, क्योंकि इससे जो भी बनता है, जो भी पीसीबी बनता है, काफी प्रिसाइज बनता है बेसिकली, ठीक है। हाँ या डैनियल यू कैन कंटिन्यू।
That's it. You have multiple stuff. You guys just explore. Like you can't just think that yeah, I'll take one month course of PCB designing. I'll become expert. It's not that. Even people in industry have to try it. They have to learn a lot of theory, basically what's happening. If you want high communication, what should be addressed? These things. There are many protocols, there are many standards that you are. So it's more of an experience based. So what I'm trying to say is don't get disheartened, right? Because of PCB exactly everything. It's a learning process.
ठीक है, डोंट गेट हॉरिफाइड बाय टुडेज सेशन, ठीक है, कल और चीजें सीखना है, एंड दैट वुड बी फन, ठीक है, जब तुम लोग 3D में देखोगे ना पीसीबी बन जाने के बाद, दैट वुड बी टोटल फन, ठीक है, डोंट गेट हॉरिफाइड, डोंट गेट फ्राइटेंड, ठीक है, किसी को कुछ भी पूछना, कुछ भी इश्यूज हो तुम मेरे को बता सकते हो, ठीक है, डीएम में हम अवेलेबल है या तो ग्रुप में हम अवेलेबल है, आ, बस बता देना,
हाँ,
ठीक है, ओवर टू प्रणव.
Yep, I guess like that's it from all of us. Samiti, we can close the recording.